Okay, this is going to be a very quick video, mainly because the Champions League's on in 9 minutes, but also because this is only a very small topic that's just a bit tricky to navigate around, so I just want to go through a few examples. So in the last video, we showed how to find the area under a curve, specifically the area between an x-axis and a curve using integration. But what if I have a setup, and hopefully you can see my tiny handwriting okay here, that looks like this. So I've got some coordinate axes in blue. I've got a curve y equals minus x squared plus 6. And I've got a y equals 4 line running through it. So what if I asked to find this area here? The area between the y equals minus x squared plus 6 graph and the y equals 4 line. Well, you may be thinking, just integrate it. But integration only works, at least the way we've done it so far, when our bounds are here. We can only find the integral of a function, the area under a function, going all the way down to the x-axis. But here, I don't care about what's going on below the x-axis. If I was asked to find this entire area under the red, it'd be easy. I just integrate that and pop in my coordinates. But unfortunately, that's not the case. So how do I deal with this? Well, let me sketch this out without the coordinate axis, just to kind of make it look a bit simpler. I've got this curve here. And I've got this area here. And I know that by integration, I can find the area that goes all the way down to the x-axis, all the way down to here. That's the area I can find. So the question becomes, how can I use that information to find this little one up here? Well, it's just the area of a compound shape. What I'd like to do is I would like to find the edges of the area that I want to deal with, which is here and here. And I would want to draw lines that go straight down to the x-axis. So I'll do it on both just so that we're clear. Because again, integration will give me the area from the top of the curve, no matter where that is, down to the x-axis. And now, what I'm left with is this shape here. In fact, I'm even going to delete these weird curves on either side, just to make things look a bit nicer for myself and more visually appealing. And I've essentially got one kind of half circle looking thing and a rectangle. Well, I know that if I now integrate this curve between this point and this point, it will give me, oh wow, that is horrendous. Let's try that again. I do. If I integrate that, it will give me this whole area here. So if I just want to get this area here, well, I can subtract the area of this rectangle, which hopefully we should be able to find by now. If we can't find the area of a rectangle, not sure what we're doing in the middle of a calculus playlist. But I can simply integrate under this, between this point and this point, and subtract the area of that rectangle. Okay, that was a lot of wishy-washy stuff. That took way too long. So let's get started. First things first, I need to find the coordinates of these 2 points here. And well, those points there are the intersection between y equals minus x plus 6, minus x squared plus 6, and y equals 4. So I'm simply left with a equation to solve like this, equating them to find those points. So I end up with that 2 is equal to x squared, minusing the 4, adding the x squared. So x is equal to plus or minus root 2, which is delightful. I really wish I'd picked better numbers, but you know what, we'll go with it. X is plus or minus the square root of 2. So here I've got root 2, and here I've got minus root 2. So to find the area of this horrific looking blue shape, I'm going to want to integrate between minus root 2 and plus root 2 minus x squared plus 6 dx. I'm going to kind of delete some of my working as I go because I think the diagrams are more important than the random algebra. And again, you can always rewind. I can't. So let's integrate this. So what's the integral of minus x squared plus 6 dx? Well, minus x squared, minus x will stay. Let's add 1 to the power. So the power becomes 3. Then divide everything by that new power. So minus x cubed over 3. Plus, well, 6 will become 6x. And then from there, I don't need a plus c because it is a definite integral. So I can stick my brackets around that and throw in minus root 2 and root 2. Okay, so again, just remind ourselves, the upper bound is going to go in first. So I get minus root 2 cubed. Oh, this is not going to be very nice, is it? Over 3 plus 6 times root 2. That's my upper bound. And then I'm going to minus when I put in my lower bound. So that'll be minus root 2 cubed over 3 plus 6 times minus root 2. Now, if I just quickly calculate that in my head, I get 15.08. So, 15.08 units squared. Haven't got any units yet, so we'll stick with units squared. That is the area of this blue thing. So to get the area of my red, I need to subtract the area of the green. Well, that's just a rectangle. That rectangle is going to have a base of, well, we're going from minus root 2 to plus root 2. So it's going to be root 2 plus root 2. So draw my rectangle. Got root 2 plus root 2, so I've got 2 root 2 down there. And then the height of my rectangle, well, I know that's going to be 4 because that's the definition of this green line. That it is y equals 4. So that rectangle is going to be 4 times 2 root 2, which is 8 root 2, which is 11.3 units squared. So to find my final answer, I'm just going to subtract that from that, and I will get, in fact I will do this one in my head, just to prove I can, 3.78 units squared.